are going to discuss this problem. So the problem states that we have a cylindrical boiler and that the cylindrical boiler has a volume of 1,340 cubic feet. And the cost of the metal sheets to make the boiler should be minimum. What should be its base diameter in feet? So if you are going to go back in the concept that you have learned in solid mensuration, which I have been your professor also. You would recall that we discussed the different formulas regarding volumes and areas of cylindrical objects. So the concepts, the formulas that you have learned will be very much useful in solving this particular problem. So let me discuss with you the problem. Let us begin with the given data here. So we have a cylindrical boiler. The volume is given. So let me draw the figure first. We're going to draw the figure. This is a cylindrical boiler. So this is the most probable figure that we can have for the cylindrical boiler. Okay. And then of course you have the diameter. These are the dimensions. These are the properties of the cylindrical boiler. So we have the diameter, and of course you have the height of the boiler. Okay. Then the height of the boiler. And since we are given here the volume, which is equals to 1,340, the unit is cubic feet, then we are going to use the formula for the volume. So what's the formula for the volume for a cylindrical object? For the cylindrical object, the formula for the volume is simply the area of the base multiplied by the height. Okay, we're going back into the principle of solid mensuration. So the area of the base multiplied by the height is equals to the volume. And take note that the the um, the base is a circular section. So that means we are going to use the formula for a circle. So the area of the circle could either be, we can use two formulas for circle. You can use pi d squared over 4. Let me just show you the area for the base. Pi d squared over 4 if we are using the value for the diameter, or we can use another formula which is equals to pi r squared. So if you are going to determine the area by means of the diameter with respect to the diameter, uh, we can use the pi d squared over 4 formula, or the area for the base can be pi r squared. Can you see what I have written down? Can you still see what I have written down or not? Okay, so we have two formulas that you can use in terms of diameter or in terms of radius. But since according to the problem, we have to find the base diameter in feet, so we might as well express the area of the base in terms of the diameter. So there are two formulas as I have mentioned which you can use. Okay? You can use pi d squared over 4 or pi r squared. But since remember that the question is the base diameter in feet, then we might as well make use of the formula for the area of the base relative or in relation to the diameter. So the question is that the cost of the metal sheets to make the boiler should be at the minimum. So that's why it is a problem regarding maxima and minima. In this particular case, we would like to make the cost for the metal sheets to make the boiler set at a minimum value. So, ibig sabihin, at the minimum value of the material cost for the material for the metal sheets for the cylindrical boiler. So, since we are given here, the value for the volume is 1,340 cubic feet. And that take note that the area is of the base is a circle, so that means we can use pi d squared over 4. So given this value for the volume, we can express 1,340 cubic feet, express it in terms of pi d squared over 4. We have pi d squared over 4. Can you still view what I have written?
Yes, ma'am.
So, that means if we are going to determine the volume, all you have to do is to multiply the area of the base by the height. So in that case, since the volume is equals to 1,340 and that we have the formula for the volume, which is equals to pi d squared over 4, then that means the volume is simply equals to 1,340 is equals to pi d squared over 4 times h. Take note that we have two dimensions or two properties here which are unknown, the diameter as well as the height. But take note that we have to minimize the cost. So for the cost to be minimum, to make cost at minimum, okay, what we are going to do is to minimize also the area. Okay, so we have to minimize the area. Since we would like to make the costs of the metal sheets to be used to be set at a minimum value, the area should also be set at the minimum. Okay, so the area of the metal sheets should be at the minimum. Okay, remember, kung gusto natin mapaunti yung cost natin dito, syempre kailangan mas maunti din yung area na gagamitan natin. So what we are going to do is to make the cost to set at a minimum by setting the area at the minimum also. So take note that according to the formula for the area, this is a cylindrical object. How do you determine the area? So the area is simply the area of the base multiplied by the area of this side. Okay? So if you are going to, let's say for example, this is the cylindrical container. This area of the base, so there are two bases, and then you got to determine the total area of the metal sheets to be used for the entire section. So that means this height, you just multiply it by the circumference. Okay? So from here, from this point up to that point, balik ulit tayo doon. So that is a circumference of the circle. So you just multiply it by this height to determine this total area of the material. So that would mean also that if you are going to set the area at a minimum, then we are going to use area of the base, which is pi d squared over 4. But take note, there are two bases here. So you have at the top and at the bottom. So we are going to multiply it by 2. Then we are going to add, as I have mentioned, the metal sheets will be covering the entire side of the cylindrical container. So the entire side of the cylindrical container is simply equals to height multiplied by the circumference. So that would mean we will have the circumference is equals to 2 pi r or pi d. So we are going to add pi times diameter, which is the formula for the circumference, and then you multiply it by h, which is the height. So the circumference is simply equals to pi d or 2 pi r. So since we are expressing all units in terms of the diameter, so we might as well use the formula for the circumference, which is equals to pi d. So the circumference multiplied by the height is simply the area to be used for the entire side of the cylindrical boiler. So we have pi d squared over 4 multiplied by 2 because we have two bases here, plus the area for the side, which is equals to pi times d times h. So that means the area is simply equals to pi d squared all over 2 plus pi times d times h. So that is our formula. And take note that we have, if you are going to determine pi d squared over 4 times h, okay, so you can say pi d squared over 4 times h. Okay, so you have pi d squared over 4 times 2 plus pi d squared. So that means we can use the formula for the area using the volume. We will have the area, which is equals to pi d squared over 2 plus pi times d. If you would like to determine the value for h, remember from the volume, if you are going to determine the value of h, all you have to do is to multiply 1,340 by 4, divide it by pi, divide it by d squared. That is if we would like to express h in terms of d. So h, therefore, let me insert the formula for h here. H will be equals to 1,340. You multiply it by 4, divide it by pi times d squared. Okay, so we express h in terms of the diameter. So that would mean if you are going to use h is equals to, that would be h is 1,340 times 4. 1,340 times 4 divided by pi d squared. Okay. So we now have, this one is 1,340 times 4 divided by pi divided by d squared. We express the value of h in terms of the diameter using the formula for the volume. So now we will have area is equals to pi d squared over 2. And if you are going to cancel out pi, cancel out pi, cancel out one of the d's, then we will have 1,340 times 4 divided by d. Okay, so you have pi d squared over 2 plus 1,340 times 4 divided by the diameter. And since we are going to set the cost at the minimum and by setting the area at a minimum, then we are going to differentiate this formula for the area relative to the diameter. So the change in area divided by the change in diameter, dA over dd, is simply equals to. So now we are going to apply the formula for derivatives. You have pi d squared over 2. If you are going to differentiate it, constant yung pi over 2 natin. So that would be 2. That is the exponent of d. We are going to use that as the numerical coefficient multiplied by pi. Then d will be equals to 2 minus 1. The exponent of d will be 2 minus 1. Okay, all over 2 plus. You have 1,340 times 4. That is a constant. And if you are going to determine the differential of 1 over d, you just simply make use of ito, ano na to, shortcut. Tinuturo ko sa inyo shortcut na ha. So, 1,340 times 4 by the formula, yung u, ddx of u over v. Okay, ddx of u over v. That is ddx of u over v, wherein u is 1 all over d in this particular case. So, remember that you have the formula for the quotient. Okay? So, for the derivative, the quotient formula. I'm just going to show you the shortcut method. So, you have 1,340 times 4, it's a constant. And all you have to do is to square the denominator, which is d. Okay? So, just square. Pag ganito yung form natin, all you have to do is to get the square of the denominator. That is for the derivative. Okay? So, we have dA over dd is equals to, cancel out the value for 2. So, that means you have pi d plus, you have 1,340 times 4 all over d squared. And for us to determine the value of the diameter, we have to set the derivatives to 0. So if that would be the case, then we will have by the way, this would become negative. Okay. This would become negative. So this would be pi times d is equals to, transposing this to the other side of the equation, 1,340 times 4 divided by d squared. And that would give us the value for d, which is equals to, let me just calculate. If you have the value, that would be equal to 1,340 times 4 divided by pi. One 1,340 times 4 divided by pi. Then we are going to get the cube root. Okay, then we are going to get the cube root. That is 11.95. So the value for D is 11.95. That would be pi times D cube It's equals to 1,340 times 4. And therefore, we will have the value for D, which is equals to 11.95. And we are going to set this to be in feet. This will be our answer. Right? So we have 11.95 feet.